Okay, so let's actually continue with our weird definitions of, like homogeneity, homotheticity, and such. But as I mentioned, we'll see what they mean. Okay, so they're not that bad, right? There's some mathematical concepts, but they have some sort of a meaning, and we'll try to give even, more meaning to homotheticity. But basically, so now you guys figured out that, hocam, apparently if we take the function itself as its transformation, right? If we take this transformation, then we can actually show that all homogeneous functions are homothetic, okay? But not vice versa. Now, let me write you another claim, sort of. And then we'll try to show that this is the case. And then you'll see that now these will start giving us some intuition of what this homotheticity means. Okay? So we actually said that if our utility function, okay, is homothetic, if our utility function is homothetic, it will have a nice property that marginal rate of substitution will depend only on the ratio of the goods. Basically y over x, not on total quantities of the goods. So what does this mean? We'll see, and we'll prove this. Okay? Now here we have this claim. Apparently it says that if it's homothetic, then marginal rate of substitution only depends on y over x ratio. It doesn't depend on y only, it doesn't depend on x only, but it depends on their ratio. That's it. So now let's see this. So why this is the case. So let's try to see why this is the case. And then we'll try to give intuitive meaning. And as I promised, we're going to link this to Rahmi Koç and Akbaba, or Mehmet Amca on the street. Okay. So now let's actually look at this. So what is MRS? Remember, MRS is the ratio of the marginal utilities. You guys know. So suppose if the utility function. Bunu da çok güzel çizmişim. So your professor's drawing abilities are great. So this is, right? Basically, so what is, if it's a homothetic function, we know that there is some h, we can always find some homogeneous function and some transformation such that, right, that u tilde function is actually homothetic. So now let's think of this u tilde. Basically, u tilde x, u tilde y, right, the ratio of the partial derivatives. You guys know that, hocam, del h, del u, del x1, del h, del u, del x2. This we have proved before, remember? So these guys cancel out. And then we are left with, so this is nothing but u of x, this is nothing but u of y. But what is specific about u? U is, u tilde was homothetic, right? Mm-hmm. So, but u is homogeneous, right? Or sometimes they say homogeneous. So it's actually, so this is, I know that u is homogeneous. So what I can do is basically, so what is this? This is u1 xy. This is u2 xy. So if u is homogeneous, what do I know about homogeneous functions' first derivatives? They are if U is homogeneous of degree K, so this is actually what we said, right? So since, let's write this, since UXY is homogeneous of degree K, what about these U1? U1 will be homogeneous of degree K minus 1, right? So this is because it's partial derivative, right? It's derivative. So since this is homogeneous of degree K, we know that its partial derivatives are homogeneous of degree K minus 1. Okay? So now let me write this, which means that U1, when I multiply all the arguments by T inside U1, this T pops out as K minus 1 U1 XY. And for U2, and this is true for all the partial derivatives, T, so this is K minus 1 U2 XY, okay? And then you can actually say for all T greater than 0, okay? This is what we know. So you can actually say hence. Then we know this is the case, but here I have U1 over U2, so let me try to write U1 over U2, XY. So here it's going to be, right, T to the power 1 minus K, U1 TX TY, U2 XY is equal to T to the power 1 minus K. So I'm just trying to get U2 and U1 by itself, okay? So U2 TX TY. Now let me write them here. What is this? T to the power 1 minus K U1 TX TY divided by T to the power 1 minus K U2 TX TY. Is there anything that is not clear here? I just use definitions. So these guys cancel out. So I'm left with what? It turns out that MRS equals to U1 TX TY divided by U2 TX TY, okay? And this is true for all T greater than 0. If this is true for all T greater than 0, then pick T, because it's true for any T, right? Any numbers that is greater than 0. Any real number that is greater than 0. So let me pick T 1 over Y. Whatever Y you pick, I'm going to take, because it's, you know, like for any number, it's correct. So pick T equals to 1 over Y, okay? Now, what's going to happen? Then MRS, if I put 1 over Y here, it's going to be U1 X over Y. And when I put, instead of T 1 over Y, that part is 1, right? So these are not tricky questions, okay? So so this is also X over Y, 1. You see, this marginal rate of substitution is actually a function of only X over Y. Of course, it's going to be a function of this functional form U1 or whatever, but it's not, if the function is homothetic, you won't have MRS like this, X over Y plus Y, for instance, okay? You might have X over Y to the power alpha, blah, blah, you know, like it might depend on the parameters, it might depend on some constant, whatever, but it's not going to actually X over, but you are not going to have, it won't depend on the actual value of Y or X, okay? So it's very important that it is only going to be a function of, so this is not the case, right? If it's homothetic, you will never get something like this, okay? So it's actually, all right, so keep this in your mind. Now, we'll see what this means, okay? So let's actually have this. So let's put this and then say that only depends on X over Y. only depends on x over y ratio. But as I said, it might depend on some parameters of the utility function and such, but x and y, they don't appear by themselves, okay? They would always appear as ratios. So what is important is actually that, okay? Now, this is basically what we meant by this. So for instance, remember we said that CES function, so this is actually the case. So CES function is actually homothetic, okay? So let's check whether, so CES function is homothetic, so let's check whether marginal rate of substitution only depends on the ratio or not there, okay? So do you remember the MRS for CES? This is what we found in our previous class. So what was it? You guys tell me from your notes. What was it? It was alpha over beta.
Times x over y.
Right, so this is, so let's actually think of for CES. Let's check. So CES is actually a homothetic function, okay? Hence, if CES is homothetic, then Cobb-Douglas is homothetic. Perfect substitutes, right? Leontief, or perfect substitutes, or Leontief perfect complement, they're all homothetic, right? So basically for CES, what was the MRS? You guys were telling me alpha over beta times x over y to the power 1 minus
P minus 1.
So this is rho minus 1, okay? It's not p, it's rho, okay? So just, it's actually a wiggly p, okay? So it's basically, so it's rho. So you see that, it's homothetic and MRS, does it depend on the actual value of x? No, right? It all only depends on x over y ratio, okay? So just keep this in your mind. It is pretty important, okay? Now, but why do we care about hocam? Okay, but why do we care about homotheticity, okay? Now let's try to see so why it is important, right? It doesn't sound like a very nice concept. It seems a bit abstract, but why it is important, okay? So let's actually draw this. What does it mean? It means I have y and x here, okay? And then being homothetic tells me, okay, the following. Suppose I have my indifference curve and I have point D, okay? So it says that the marginal rate of substitution at this point D only depends on the ratio of x and y at that point, x, y, okay? Now, let me draw you a ray. What is a ray? Do you remember? Işın. So it was, how was it different from, like any sort of linear, or how it was different from any line? It goes through the origin, right? So that's actually, so this is, so you see this is, so what is the slope of this? So let's call this alpha. So what is the slope of this ray line? It's y over x, right? So suppose I have a point here. And let's say, or let's have this point here. Okay? So what is the, of course this doesn't look like a ray, but so let's have a point here. So what is the ratio of y to x? So let's call this x prime, y prime. What is the ratio of y to x here? Is it the same or different? So you said that it's there along the same ray, right? So here at point D, it's y over x, right, at point D. So let's call this point, I don't know, E, okay? or let's put A for Akbaba, and this is for R for Rahmi Koç, okay? So this is, and this is Y prime over X prime. What about these ratios? They are, because they're on the same ray, right? They're the same, right? So what does that mean? If MRS at this point only determined by Y over X, then what does this tell me? Suppose Rahmi Koç is here. Okay? So obviously, so remember these are the amount that you consume. We haven't talked about income and such, but right, so maybe Akbaba is maybe happier than Rahmi Koç, those we don't know. But we would assume that Rahmi Koç, he's able to consume more of both goods, right? Probably that's the case, right? But what does this say? So let's say Rahmi Koç is on a utility, you know, like on an indifference curve like here, on the utility curve here, let's say, and then the poor Akbaba is actually here, okay? So, but what does it tell? What do I know about MRS of Rahmi Koç at this point, R?
When we increase x,
Huh.
the amount that we give up from y is same.
So what is it? Even you don't have to give the definition. What can I say is that MRS at A is and MRS at R. They're equal, right? So you see that but this only happens if the utility function is homothetic, okay? So it says that even if, you know, Akbaba is here, but Rahmi Koç is here, let's say this is U0, or let's say U1, and then this here it's U, I don't know, 1000, okay? But you see that even Rahmi Koç is on such a higher indifference curve, actually this indifference curve and this indifference curve are kind of, you know, pretty much, you know, like, it's basically what we say, this is like, this one is a radial blow up of this one, right? This lower indifference curve, okay? So basically it means that because marginal rate of substitution is only depending on the ratio, along a ray, if I have another indifference curve here, I know that MRS at this point is also the same, okay? So you see that it's very important because this tells us the following. If we know, suppose Rahmi Koç and Akbaba, they have exactly the same utility function, right? Same preferences and the, you know, like same utility function that represents those preferences. But we know that, which we haven't, you know, like considered, but we're going to consider that there is also, right? We haven't considered the budget constraint part. But suppose they have the same utility function, okay? Suppose they have the same preferences and represented by the same utility function. It says that if I know Akbaba's, for instance, indifference curve, I can actually get Rahmi Koç's indifference curve, right? Because it says that I know that Akbaba's indifference curve is like this, MRS at this point is this, and then Rahmi Koç's MRS at that point will be that, okay? And I can actually think of another point, let's say, so let's say this is theta, right? So I have another point, let's call it B, and it turns out that the MRS at B and MRS at this point, they are also the same, okay? So basically, it's, so when I know this indifference curve, I can actually figure out these higher indifference curves as well, okay? So that is what we mean by homotheticity, okay? So you can have different interpretations. One of them, you can actually say that marginal rate of substitution is the same along a ray through the origin, right? Because you would say the hocam, because y over x ratio along that ray is the same, marginal rate of substitution only depends on y over x ratio. That's why along this ray, all the MRSs are the same, okay? And along this ray, all the MRSs are the same, okay? So this is kind of how we would interpret, okay, what's going on. Let me give you another. Did you get this? Is it clear? Okay, so that is the link. So it turns out that if I know Akbaba's lower indifference curve, I can always figure out what's going on in Rahbi Koch's, world, sort of, okay? So basically, this is actually the case. So these are like just radial blow-ups of lower, so higher indifference curves are just radial blow-ups of lower indifference curves, okay? So that is basically the case. Or you can say that, hocam, along a through array, on a ray through the origin, all the MRSs are the same. I know, okay? So let me give you another. So it means that if I know one indifference curve, I would know the entire map. And this does not have to be the case, okay, all the time, only with homothetic preferences, okay? So let me actually give you another definition or another interpretation. So about the homothetic utility function, actually you would sometimes hear that preferences are homothetic, okay? But it's very much related to what we have said there. So let me write this, homotheticity in terms of preferences. So basically, in terms of preferences, homotheticity is the following. But remember, we didn't like working with preference relations and such, so we wanted to work in the function world, right? So basically, but we actually say that a preference relation is homothetic. So let me tell you this. A preference relation is homothetic, okay, if for any two bundles, so call it x1 and x2, okay, such that x1 is indifferent to x2. Don't forget that this x1 and x2 might have n goods, right? So if it says that x1 is indifferent to x2, right, basically then alpha x1 is also indifferent to alpha x2, okay, for any alpha positive. So what does this mean? And its relation to whatever we have said there, it's like this. Suppose x1 is this, x1, y1, x2 is this, x2, y2, okay? So it means this. If I know that x1 and x2 are on the same indifference curve, right? Basically, I know that x1 and x2 are on the same indifference curve. Then if I make them alpha x1, suppose I just blow this up. Now here it's alpha x1. I also blow this up, alpha x2, okay? Then what do I know? This alpha x1 and alpha x2, it tells me homotheticity means that they are on the same indifference curve, right? So that's basically it. So you see that it's actually a nice property that says that when you just, like, let's say you double the goods, x1 and x2, let's say, and then you're going to actually, so suppose you double both of your goods, and you double these goods as well, this bundle as well, those doubles are also on the same indifference curve, okay? So this is basically the case. If it's homothetic, because it's true for any alpha, no problem. But in real life, of course, you see, these are all special cases. So it could be, so I mean, your friend is right? After some points, we know that, first of all, it might not give positive utility anymore, right? More is better. You might have a satiation point, a point where you are satisfied, right? You don't want any more of the goods, right? So basically, this is actually the case. So this is in terms of, so you put it U0 and this is U1, okay? And homotheticity in terms of preferences, it actually means this. And in terms of utility functions, then it would mean, so let me actually write it down also, so that you guys would have the formal proof. But you understood, right? Homotheticity, what does it mean? So let me write it. So this is in terms of preferences, and this is going to be in terms of utility functions. So this is another sort of definition, and whichever one you like, so we provide them all. So let me write this, homotheticity, okay, in terms of utility functions. So basically, so let me write down the formal. So let U be from Rn plus to R plus. But as usual, what is important is not these definitions, what it means, okay, that you need to know. But to be formal, that's why we write down these definitions and these interpretations, so that you would have it in your notes. So whenever there's a need, you can always go back and have a look at them, okay? So suppose it's from, like, because we might have n goods, right? And they're going to be assigned some number, some utility. Be a strictly monotone function. So you might also want to know what strictly monotone function means, monotonic function. If for all x1, x2, element of Rn plus, okay? It means that if x1 is greater than x2, and this means that all the arguments are strictly greater than this other guy's arguments, okay? Remember, this is going to have n arguments, this is going to have n arguments, and this means that each argument is actually greater than this guy's arguments, okay? U of x1 is greater than U of x2, okay? So this is basically strictly monotonic. It means that if this is a higher number, think of it like this, it's going to assign a higher utility, right? So basically, this is how they define it, okay? It says that then U is homothetic if and only if, okay, for all x1, x2, element of Rn plus, U of x1, when U of x1 is greater than or equal to U of x2, if you like one bundle more than or at least as good as this guy, okay, then it says if and only if U of alpha x1 should be also greater than or equal to U of alpha x2, okay, for all alpha greater than 0. This is exactly in terms of whatever we said, in a sense, like represented in terms of utility functions, okay? In terms of preferences. Basically, it says that you have two bundles. If one is either, you see here we said the indifference. Here, this also includes indifference, right? For instance, if they give the same utility, then alpha, when you multiply them by alpha, they should also give the same utility. Or you see, if this utility is greater than or equal to this, right? This bundle gives a utility which is greater than or equal to this. Actually, then alpha times that bundle should give greater than or equal to, right? A utility which is greater than or equal to alpha times this bundle's utility, okay? So basically, this is the case, okay? So just keep in your mind, but I think the best thing is that it says that if you know Akbaba's indifference curve, it means that I can actually blow this up and then figure out, let's say Rahmi Koç is on a much higher indifference curve, right, I can actually figure Rahmi Koch's indifference curve as well. I can figure out this entire indifference map if I know just one. That's why it's very important because, for instance, this is going to, especially in macro, this is going to, if your utility functions are homothetic, this means that, for instance, let me ask you this, can I, in that sense, can I use Akbaba as a representative consumer in this entire, like nation? Yes, right? Because when I know his stuff, I can figure out, let's say Rahmi Koch is here. So let's say, I don't know, we're better than Akbaba or worse. So let's say we're better, okay? So let's say, like we are here. So you can actually figure this out, right? Everyone else's indifference curves. But basically, if the utility function is homothetic, you can use, you'll see later, but you can use a representative consumer, right? One consumer would be enough to figure out the entire economy, right? So you can actually figure out that if you can actually assume that there is one single consumer which is consuming the entire production of that country, for instance, okay? Or you can assume that, everyone is consuming equally, sort of, or everyone, okay? So this is basically, you see that you can use a representative consumer, okay? That's why you're going to hear homotheticity a lot, and that's why it's pretty important for us, okay? Now, let me show you an example. So let's solve an example. So I'm going to give you a utility function, and I want you to figure out whether this is homothetic or not. So let's see whether it is homothetic. Okay. So this is an example. Okay. Now suppose we have a utility function like this. U of xy, which is equal to x to the power 1 over 2 plus y. This function, this type of utility function, has a special name, okay? It's called quasi-linear. Okay? But now let's try to understand why it's called quasi-linear, okay? Now, this is quasi-linear, so if you want to draw this, but let's try to check first whether it is homothetic or not. What do we learn about homotheticity? We learned like many definitions, but remember, whenever we need to show some stuff, our tool was what? What were we using to show convexity? MRS, right? And here we also know that, if it's homothetic, then it should be the case that marginal rate of substitution should be only depending on y over x ratio, right? If it doesn't, then we can definitely say that it's not homothetic, okay? So let's see. First, I'm not even going to draw it, but then I'll tell you why it's called quasi-linear. What is MRS? What is it? It's ux divided by u of y, right? Okay, so so this is MRS. So tell me, what is MRS? What is marginal utility of x? 1 over 2, right? X to the power minus 1 over 2, right? Divided by 1. So what is this? 1 over 2. This is MRS. Does it only depend on x over y ratio? Or does it only depend on the ratio? It doesn't depend on the actual value, right? So for instance, or think of it always like this. Suppose poor Akbaba, he's actually, consuming, what was he consuming, right? Yeşilerik, right? I think it was like green plums. And, but anyways, let's say they consume, or I don't know, whiskey, right? So let's say they have whiskey and, I don't know, green plums, right? So basically, or let's say holiday. Maybe it might be better. I think Rahmi Koch sails, right? So actually, let's say it's whiskey and, sailing or holidays, okay? So let's say poor Akbaba, obviously, probably he's not consuming much. right? He's here. And then, but we know that, like for Rahmi Koç, he might be consuming, like he can consume a lot of, like holidays, and you can measure number of days or whatever, right, hours of holiday. And, like, let's say, I don't know, whatever they like, right, whiskey or whatever, right? So is it going to be, let's say this is the amount of whiskey that they consume. It's going to be, or holidays. Do you think it's going to be different for Akbaba and Rahmi Koç? Always think of it like that. This MRS is going to be different for Rahmi Koç and it's going to be different for Akbaba. Is it?
No, yeah.
Yes, right? Because suppose, let's say Akbaba, he can only go on, let's say, on holiday for 15 days. And for Rahmi Koç, let's say he can go on holiday for, is he working? I don't know. So, okay, so let's say 40 days, okay? So basically, suppose this is X of Akbaba and X of Rahmi Koç, right? So this MRS, apparently it doesn't depend on, good Y, apparently, but it depends on, so is it going to be different for them? Yes, right? So it doesn't only depend on the ratio, but it depends on the actual amount, right? So that's why we say it's homothetic. No, right? This function is not homothetic, okay? So you see that depends on actual value of X, right? So not homothetic, okay? Showing something is homothetic is harder, but showing, it's not homothetic, it's actually, you see that it's much easier, right? So you figured out that it doesn't depend on Y over X. Okay, so we say that it's not homothetic, but where does this quasi-linear thing come from? Okay, so this is actually an important functional form. And let me show you. Yeah, you see, it's, here it's actually, right, it's a bundle of two goods, but in MRS, the other good doesn't appear.
There is a change in Y.
So let's see, so how it goes. So, and actually, let me tell you, is MRS, does it diminish? Is it diminishing here? Yes, right? MRS is diminishing, then I can say that this utility function is quasi-concave, right? So this is apparently the case. Okay, so what is MUX? MUX is this guy, 1 over 2, x to the power minus 1 over 2. MUY is 1, right? So what's happening to marginal utility? So remember, there is diminishing MRS. So is MUX, is it diminishing? As x increases, does this guy diminish? So you can actually take the derivative with respect to x, right? So it's minus 1 over 4, right? X to the power minus 3 over 2. So what is this? Is it diminishing? Yes, right? Because this is negative, given that x is positive, right? So this is basically, so this is diminishing. So apparently there is diminishing marginal utility of x. What about this guy? Is it diminishing? It's constant, right? So you see that MUY is constant. So you see there is diminishing marginal rate of substitution, but these guys, they don't have to be diminishing. You see? One could be constant, the other one could be diminishing, okay? So just keep this in your mind. Remember, we discussed this. Oh, are these the same thing? Does one imply the other? No, that's what we said. Okay, but why does it called quasi-linear? So let's try to see. If I want to draw an indifference curve, how do I draw the indifference curve? Remember, I was setting this utility function to some numbers, right? X to the power 1 over 2 plus y. So let's set it equal to 0 if you want, okay? Or c, some constant c. So this is what? Y equals to minus x to the power 1 over 2, right? So how will I draw this? What is this? So this is, right, y equals to minus square root of x. So how do we draw square root of x? So this is y, this is x, It's like this. And the minus would be, right? It's going to be, right, it's symmetric with respect to the y equals to 0 axis, right? So it would be something like this, okay? Apparently, if I put here not 0, let's say c, it's going to be y equals to c minus, right, square root of x. So basically, when it has c's, it will have these guys, right? Apparently, my indifference curves are like this. So let me draw. Y, x, okay? So let me draw my indifference curves. Apparently, my indifference curves are like this. So let's call it U0, U1, U2, U2, okay? So then, and also, you know, like a similar form which would also look like this is also, just keep in your mind, this form. ln x plus y, okay? This is also quasi-linear, okay? Very similar. Now, apparently so what do you see here, for instance? Or let me ask you this. Suppose, or maybe, okay, so what about, so suppose I have an MRS, which is here, okay? So this is basically, suppose this is point x and this is point y. So I go up here. What can I say about the MRS at this point?
Same.
Why? Slope is the same, or I don't know the slope. No, we said that it's not homothetic. How do I know that MRS at that point is the same? Because x is the same, right? Because it only depends on x, right? Only x governs, right? So if I go along, remember homothetic was, it should be the same along this ray. But apparently along this ray, because x is changing, are these MRSs the same? No, right? So you see, it's not the same. But MRS is the same for the same x. So you see that MRS is going to be the same along this. So you see that apparently these indifference curves are kind of like quasi-linear shifts, right, of each other. It's not like, you know, those radial blow-ups, but apparently they are kind of, you know, like linear shifts of one another, right? So basically, so later we're going to see that suppose this is the price level and such. So it tells you that later we'll see, but just right now just keep in your mind that suppose I give this consumer more income, all this income would go to which good? Which one would you? Okay, so I want to get more utility. I have more x. As you know, like as long as I consume more x, okay, I get some utility, but what's happening to the additional utility I get? So it's actually x is, as I consume more x, the marginal utility I get from it, it keeps decreasing, right? What's happening to y? When I keep consuming y, it gives me, right? Once I reach apparently a decent level of x, then whatever income I get, I'm actually going to spend it on y. So we'll see. You don't know what is the optimal point and such, but just keep this in your mind and then ask me later, okay? Hocam, so what about these quasi-linear preferences? Okay, that's why it's called quasi-linear. It's not homothetic, but you see it's actually shifts along this right vertical x line, okay? So we'll continue on Friday with utility maximization.